Hello and welcome back to Chapter 3, Part 2. The next thing I want you to do is take this data and input it into Excel. So pause the video real quick and do that, and then we'll come back. Okay, the program is going to ask you to do some data analysis. Most likely the first thing you're going to have to do is go over to File here in your Excel and go to Options, go to Add-ins. See this where it says Analysis Toolpack? Go ahead and click on that and go to Manage and hit Excel Add-ins and click Go, and make sure that Analysis Toolpack, both of those are clicked, and hit OK. So once you've copied that information into Excel, we'll just follow these instructions. So we'll go to the Data tab, and we'll go to Data Analysis, and we're going to choose Regression, and we'll hit OK. We'll click here and we'll highlight the cost data. So that's on our Y input range. We'll click on the X input range and highlight the move data. And we'll tell it where we want to input it. I just say new worksheet. And actually, I think, let's see if it takes the headers as well. Oops. And we'll do new worksheet. Press OK. Okay, so we can't take the headers. So don't take the headers, just take the data. I didn't know if it would take the headers and give us more titles. And press OK. And we're going to get an output that looks something like this. So once you get that output, just minimize it, or we'll come back to it here in a second. So this is what our output looks like. Yours should look like this again. And we'll talk about what that means. So let's interpret the results. So under the coefficients in the bottom left of the output, find the intercept and slope. So under the coefficient heading, so that's going to be in your column B, we have the intercept and the x variable 1, which would be our slope. So if we input that into our mixed cost equation, we have here y equals 12.39. That's our variable cost times x plus $854.50. There's our fixed cost right there. So use the equation to make a point estimate at point of 350 moves. The total cost is predicted here. So we get y equals 12.39 times 350 plus 854, or $4,336.50. So we can use this regression to grab our slope and our fixed cost based on the scatter plot data, and then create this this equation to estimate other fixed costs or other points on our graph. So there's three statistical assessments concerning the cost formula's reliability. We have the hypothesis test of cost parameters, the goodness of fit, and the confidence intervals. So the hypothesis test of cost parameters uses the t-stat test, and tests the hypothesis that the parameters are different from zero. The p-value is the level of significance achieved. Generally, a p-value of 0.05 or less is needed for significance. So otherwise, our information is statistically insignificant. We can't rely on it. So the goodness of fit measures is the coefficient of determination, or R squared, shows the percentage of variability in the dependent variable explained in the independent variable. So we can see that in our output here that we use for regression. So since R squared is the percentage of variability explained, it always has a value between 0 and 1. Typically, the adjusted R squared is used because this value has been adjusted for the number of variables included in the equation. And the coefficient of correlation. It is the square root of the coefficient of determination when there is one independent variable. It has a range between -1 and 1, and the higher the magnitude, the greater the correlation. A coefficient of correlation value close to 0 indicates no correlation. So if we look at the correlation illustrated, we can see machine hours and utility costs under the positive correlation. As R approaches positive 1, we see machine hours and utility costs going down. And that would be a positive correlation. If there's a negative correlation, we might see hours of safety training going up as industrial accidents are going down. As R approaches -1, the hours of safety training would go down and industrial accidents go up. So that's where we see negative correlation. As one goes down, the other goes up. If there's no correlation, there's no rhyme or reason between the two variables. So R would be getting close to 0, and we would see hair length as it correlates to accounting grade. If it goes up, the accounting grade will not likely change. If it goes down, again, the accounting grade, there's not going to be any correlation there, and that's what the R value will show you. Reliability of cost formulas, confidence intervals. Y sub F plus or minus TS sub E. This formula is for calculating the desired level of confidence. Y sub F is the predicted cost for a given level of activity. T is the T distribution. Get this from a table in the table in your book. You can look up the T distribution table and grab those. And then S sub E is the standard error shown in the regression output. So the table of selected values for a T distribution is shown here. And a T distribution is literally a probability distribution that's used to estimate population parameters when a sample size is small or when the population variance is unknown. So if we look at a multiple regression, whenever least squares is used to fit an equation involving 2 or more independent variables, the method is called multiple regression. In the case of 2 explanatory variables, the linear equation is expanded to include the additional variable. So y equals f plus v1 x1 plus v2 x2, where x1 equals the number of moves and x2 equals the number of pounds moved. So adding another independent variable might increase the explanatory power of our model. Performing the regression is very similar to simple regression. Input the data and make sure the 2 independent variables are side by side and follow the same directions, but select both independent variable columns for the input x range. So if we added this information to our Excel worksheet, we would get an Excel sheet looking like this. So then if we go to data analysis, again choose regression. So for x or the y input, we're going to do the same thing, but for the x input, we're going to highlight both of these columns instead. We'll output to a new worksheet, and we get something that looks like this, which is the same as they show us here. So to interpret these results, under the coefficients in the bottom left of the output, find the intercept and the slope and write the equation. So we have y equals a fixed cost plus 2 different variable costs, x1 and x2. So we have our fixed cost of 507.31 plus 784 times x1 and 11 cents times x2. So we can examine the reliability of our new model. The adjusted R2 is 99%, a significant improvement. The p-values are all very good as well. So if we look at the p-values, we see that they're in a much better range. And the t-statistics drops to 7 degrees of freedom because another independent variable is used. So these are all good things. So we have much more reliable data. The learning curve shows how labor hours per unit decreases as units produced increases. The experience curve relates to cost increase efficiency. The more you perform a task, the lower the cost of doing it. So if we go back to our table or our thing here, so here we see machine hours and utilities, hours of safety training to industrial accidents. So that's what we're talking about here with our learning curve and our experience curve. So cumulative average time learning curve states that the cumulative average time, oops, what happened here? The cumulative average time per unit decreases by a constant percentage. The learning rate is expressed as a percent. Incremental unit time learning curve. The incremental unit time learning curve model, it decreases by a constant percentage each time the cumulative quantity of units produced doubles. So if we look at a cumulative average time learning model we see here, we can see a few things. As we see the number of units go up, the cumulative average time per unit goes down. So even though the cumulative total time goes up, the total, or again, the average per unit is going down, and the time for the last unit continues to go down as well. So we can see that represented here. So the cumulative total hours required, it's not a straight up line like this as we see for these first 5 units, because it would keep going this way, right? It would keep going way up here. But it actually curves off, and the cumulative average time per unit is going down as the number of units goes up. So managerial judgment. The most widely used method in practice is managerial judgment. Managers may just use their experiences and observations to determine fixed and variable costs. And why do we think this is the case? Well, most likely because it doesn't require the capturing of additional data, which is a lot of extra work. It's a lot of work to capture and analyze additional data. So managers may identify mixed costs and use experience to determine what part is fixed, thus denoting the rest as variable. This is a simple method and can yield good results when the manager has a good understanding of the processes. However, poor judgment yields poor results. Just like systems, garbage in, garbage out, bad judgment yields bad results. So that brings us to the end of chapter 3. I believe I'm going to go in and try to post some supplementals for some of the problems in the book in Cengage for this chapter, so we can work through them. But practice making sure you understand how to perform the data analysis there in Excel. And remember to get your homework done, and please remember that if you have any questions, let me know. And I'm here to help you, assist you, answer your questions. We can meet online or just over email, whatever works for you. Thank you for viewing Chapter 3. God bless you guys this week. I didn't grab a verse for this week's videos, but maybe I'm sure I'll post one in the announcements, and we'll talk more about it as the course goes on. So again, thank you for viewing Chapter 3, and I look forward to the rest of the course.